Hello and Assalamualaikum everyone. So today we'll be presenting our CHM256 Analytical Chemistry presentation titled Application of Chromatography in the Food and Beverage Industry. But before we actually begin, let me introduce myself and my fellow members. My name is Nur Fazira. Here we have Muhammad Nashrul, Anastasia, Muhammad Marwan, and Siti Aisyah. And without further ado, let's begin. The first part of today's presentation is introduction. So chromatography is a crucial analytical technique in the food and beverages industry used to separate, identify, and quantify components within a mixture. It helps ensure quality, safety, and compliance with regulatory standards. Through methods like gas chromatography and high-performance liquid chromatography, manufacturers can detect contaminants, verify ingredient authenticity, analyze flavors and aromas, and monitor nutritional content. This precise and efficient analysis is essential for maintaining product integrity and consumer trust. So, the objective of today's presentation is to explore how chromatography is used to ensure food quality, safety, and flavor analysis. So in this presentation, we'll be going through the theory, methodology, examples of results, and conclusion.
Theory of chromatography. Basic principle. Technique that use to separate mixture by two phase of interaction. The two phase interaction is stationary phase and mobile phase. For stationary phase, it's a component of a mixture are absorbed or dissolved in the stationary phase to varying degree. It used for interaction with components of the mixture affecting their rate of travel. It can use for a solid or a liquid and supported by a solid. Meanwhile, mobile phase is a technique that uses fluid that move through or over the stationary phase carrying the component of the mixture with it. It transports the mixture component through the stationary phase. It can be used for a gas or a solid. Type of chromatography. There are three types of chromatography. First, gas chromatography. It's a technique used for separating or analyzing components which can be vaporized. The stationary phase is a liquid or solid absorbent inside the long column, and the mobile phase is inert gas. Volatile components in the mixture are carried by the gas through the column where they interact with the stationary phase. Second, liquid chromatography. Technique that used for separation of non-volatile component. The stationary phase is a solid or liquid on the solid support for stationary phase. Meanwhile, the mobile phase is liquid solvent. Components of the sample are separated based on their interaction with stationary and mobile phase. Third, thin layer chromatography. It's a simple technique and quick method used for qualitative analysis of mixture. The stationary phase for the abundant material coated with flat substrate, and the mobile phase is a solvent. A small spot of sample mixture is placed on the TLC plate, which is then placed in a solvent. As the solvent moves up the plate by capillary action, it carries the component of the mixture at different rates.
So now let's move forward to the methodology for chromatography. So first is the selection phase. Stationary phase, or SP, is a solid or a liquid that is immobilized on a solid support, for example, silica gel, alumina, or paper. And then mobile phase, MP, is a liquid or gas that moves through the stationary phase, carrying the mixture components with it. And next is the preparation of the column or planar surface. For column chromatography, the column is packed with the stationary phase. For planar chromatography, the stationary phase is prepared on a flat surface such as paper in paper chromatography or a glass plate in thin layer chromatography TLC. And then for the third one is the introduction of the sample. The sample mixture is introduced at the top of the column for column chromatography or a starting point on the planar surface for planar chromatography. Next is the elution process. The mobile phase is then passed through the column or over the planar surface. The components of the mixture interact with the stationary phase to different extents based on their affinities. Components that have a stronger interaction with the stationary phase move slower, while those with weaker interactions move faster. Moving forward is the detection and analysis. As the components separate, they can be detected and analyzed as they exit the column, eluate, or as they are distributed on the planar surface. Techniques such as measuring the retention time in column chromatography or calculating the retention factor RF in planar chromatography are used to identify and quantify the components. And then, calculation of retention factors RF for planar chromatography. The retention factor RF is calculated as the ratio of the distance traveled by the substance to the distance traveled by the solvent front. RF is equals to the distance traveled by the substance over distance traveled by the solvent front. And last but not least is partition and adsorption. In partition chromatography, the separation is based on the distribution of components between two immiscible liquid phases. In adsorption chromatography, the separation is based on the adsorption of components on a solid stationary phase.
Next, we move to the part example of results. In summary, this table allows us to evaluate the effectiveness and reliability of the recovery methods used for different pesticides across various fruits and vegetables. It highlights the importance of considering both the mean recovery percentage and the RSD to ensure accurate and consistent pesticide residue analysis in fruit safety testing.
Now we reach the conclusion of this presentation. To conclude this presentation, chromatography is really important for maintaining the safety and quality of foods and beverages. There's still a lot of research regarding to this topic, so that more things can be improved in the future. The advancement of chromatography is necessary to ensure the highest quality standard, not just food and beverages, but also other things like medicine. High standards in quality of food and beverages can give more healthier choices to people. All in all, this topic should not be taken lightly and the advancements must go on for the greater good. And as you can see right here, this is our reference for this presentation. And that's all from us. Thank you for watching this video and we hope you really enjoy it.